Good morning, everybody. It's week 15 today. I'm very close to the end of the semester, and I wish everybody have a good learning during the semester. Not only in my course, but also in other courses. And something I need to say sorry because I have been busy for 3 or 4 months, and it was horrible. But I have no excuses because I got a salary from the campus. I obligate to take care of all students. That's my obligation. I should do it. I shall do it. Okay. And I hope if you have any problem about the statistics or the academic writing and presentation, please let me know. I'm always on the internet. Please line me anytime. I'm be happy to answer any question within my ability. Okay. Today we'll continue to introduce the concept about chi-square, and again, the pioneers, the scientists, they created the principles and formula. Actually, it's very hard to understand because we are not those smart scientists. We are not. I'm not either. But after they created those formula to solve some kind of problems, then we can learn, we can learn their method. It's easy to run. Today, I will show you how to conduct two kinds of chi-square tests. One is goodness of fit. The other one is independent test. And those are really useful in the future. Actually, chi-square test in some situation, they is very useful in business field, but not how can I say that? It's more applicable and useful in business field. But in my field, biology, is okay. The importance is so and okay. And today we are going to see this one. The first one, I will explain chi-square goodness of fit. And second one, I will explain the test of independence. Actually, I don't like the term independence because it's not a plain English. Even if translated into your language, it's not a plain English. If I use my own language to explain the term independence, I will use one sentence. Are they the same? Or easy. Okay. Are they identical? And for example, previously I used an example to explain this. For example, the body weight of body weight of man in Taoyuan and the body weight in Hsinchu. Well, do they have different body weight? Those males in Taoyuan and Hsinchu. Maybe yes, maybe no. We don't know. Okay, but we know something. The average body weight from the US, the man and the man in Taiwan, completely different. We know because the obesity, not overweighted, obesity is a serious problem in the US. So we believe that the dependence, we say yes, the average body weight from the US is different from body weight of men in Taiwan. That is okay. And when I was a PhD student in the US, we know that the diversity of height is very broad. In Taiwan, most men, our height is between 160 to 180, very narrow range. But in the US, maybe you can see a gentleman more than 200 centimeter high. It is a very tall guy. But you can see some men in the US, the white one or the African American, they are a little bit shorter than I. I'm a middle-sized man in Taiwan. I'm middle-sized, just close to the average, not above it, not below it. And we can know that the diversity is very big. The diversity is big. Okay, now we are going to switch this one. Chapter 11.2, chi-square goodness of fit. And I already gave you the examples, or you can check here. you can go to the $1 homepage. You can type the link, or you already know it, and go to the EMI. EMI is English as a medium for instruction. IHP Introductory Statistics. Here, then go to the syllabus. Go to the syllabus. Go to syllabus. Just a reminder, the week 17 is our final exam. Again, no matter the score you got, I don't care about it. But I really care about the attendance at least 6 times. And if you want to earn extra bonus in the grading, you can do the homework. You can do the class assignment to create your own homepage. I will give you extra bonus like that. And 2 exams are essential. No matter the score you got. Okay. I think some of you already did a good performance, good job. I know that. Okay. Then next week I will tell you some different topic about this. Okay. Then go to this one. You can check this. The first example I will show you is like this. The formula is chi-square equals the sum of observation minus expectation, and take the square of it, then divided by the expectation value, where the degree, let me enlarge it, sorry, zoom in, where the degree of freedom is k minus 1. I will explain it very soon. Then here is the example. I made this example. $1 has an example. Throw a die for 600 times. Oh, sorry, I forgot times. I forgot the S here. If it is a fair die, 6 area, 6 points should have 100 times or close to 100. That is expected values. Now we are going to use the tool chi-square test to check whether the die is normal, is fair, or that is a freak one. And in the first 2 classes, I will teach you how to use traditional way to calculate. And sure, during the final exam, I will make a table. Then you need to fill the blanks with the traditional way. Easy, trust me, that's easy. And the third class, I will use how to use the software or online applications. Just type the number, 1 click, 2 clicks, then you got the answer. Very, very easy. So, but again, let me remind again. In the final exam, I will have a question or 2 questions about you need to use the traditional way to establish the form, the table, to fill in the blanks. So be concentrated on today's course. Okay, then $1 throws a die, and the probability. I observed I throw it for 600 times, and I get the point of 1 that 50 times, point of 2 60 times, 3 that is 100 times, 4 that is 100 times, and 5 that is 140, 6 that is 150. And now I want to ask whether this die is a fair die or is a strange die. Absolutely, it's strange because theoretically, every point should have 1 or close to 100 times, because you throw it 600 times in average. Each area should have 100 or close to 1, 99, 98, or 101, 102 days. Okay, but I observed the face of 1 that is 50, the point of 2 that is 60, and now you can say it's a significant differences between those 6 points. But now we need 1 more tool after the calculation. It can convince more people because you use the tool that name is chi-square test. Okay, now you can you can turn on a, let me have it here. Okay, and now, excuse me. Oh, sorry. I throw a die. The observed values are here, and now I'm okay. In this area, I have new Google Sheet. Excuse me. I type the 2024/05/29. Sorry. Okay, now I have this one. 1, 2, 3, 4, 5, 6. The die has 6 areas, and I got the observed totally. I throw 600 times, and the observed time is 1 dash 50. I think it's better now. Okay, 2, that is 60. 3 is 100. 4 is 100. 5, 140. 150. And now, if that is a fair die, what can we expect? We expect the value should be 100. Here, 100, 100, 100, 100, 100. Okay, now let me check it 600 times, and this one, to some of them, that should be 600 times. And now let's check the formula here. The chi-square value, the formula is chi-square is the sum of observation minus expectation. Take the square of it, then the value is divided by the expected value. And now we can do this. Observation is expected value, and here is the observation minus expected value, and you can click here, type equal, have a parenthesis here, minus here, and click enter. Okay, please do this step. I made up an example like this. Then we expected because the total times is 600, then we can expect 100 for each one. Let me find a cute cartoon. Then next, take square of this value and place the square value here. Let me show you how to do it. O minus E and take square of it. Remember, it's an official normal use to take the head. The symbol is for exponent. Here we use the head here. It means 2 power of the 2. Power of 2. It means square of this value. Then I can click here and type a symbol equal okay, get it? I want to know the square value of this one, so I use a symbol equal and place the cell into the parentheses, then take square of it, then click enter and pull down until the 6 points. I think it take 1 minute you can use 1 minute to do this. Okay, then I click enter. Then, okay, the Google spreadsheet has a smart function, autofill, because it can detect this value automatically. We can check it now. The square of minus 40, that is 1,600. That is correct. The square of the 0, that is 0, 2, 0, 2, and here should be 40. Here should be 40 plus the plus value 40 and 1,600. That's okay. And the value here is 50. The square is 2,500. That is okay. So I can click, check it. You can click check it, or you can move your mouse, your cursor close to there is a cell on the bottom right corner. There is a dot. Close to the dot, the cursor becomes across. Then click the mouse key, pull it down, and release the key. Get it? Guess my next step. Next step you can expect here. Oh, it's ugly. Because the resolution of that is horrible. Okay, much better. Okay, who want to guess the next thing I want to do here? reminder, the formula is here. We got the step of observation minus expectation, then take a square of it. We finished the step. Now, do you want to know my next step? Yes, divided by expectation value. Then click here, click the function, input a symbol equal. Then we know we finish the calculation of the square value. Just click it. Then come back here, input a slash. Then expected value is here, and click here. Get it? Again, our target is to calculate by this formula. Again, to use the formula, that is easy. That is easy. How to calculate the chi-square value? Sum of this part. And now we step by step. Observation is here. Here. Sorry. Okay, let me explain it again. I have done okay. Sorry, let me. Again, okay, let me review this part. Sorry, let me finish part. We can take a break. Our data throw a die for 600 times, and I got the 1 point that's 50 times. The 2 that is 60, 100, 140, 150. Then I want to calculate whether this die a fair die, a normal or a strange die. Okay, then we are going to use a powerful formula, a power tool, that is chi-square. And to be honest, the formula is easy to operate, but the principle and how to establish, how to find out, how to create this formula is very, very, very difficult. We are not the pioneers, we are not the scientists, but we just need to know how to run the application of this. Okay, now, and I have a die. The observed value 50, 50, 160, 100, 100, 140, 150. Then assume that is a fair die, that we expected the value is 100, 100, 100, 100, 6 100s here. Then according to the formula, we divide it into several steps. The first step, we calculate observation minus expectation. Observation is here, minus expectation. Sure, the value can be a negative value. Second step, try to find the square value of it. So we can click here, and you can see the function inside. You can see the function inside. We click here, and the function equals the value D5 emits here, and take a square value of it, click enter, we got 500. Then you can pull out the whole process, then we get a similar value here. And next one, how to calculate this one. Yeah, that's here without the sigma, the symbol. Yeah, we can click here, then divided by E. What is E? Expected value is here. So arrow, what's the arrow? Cannot be 0. Oh, not a C1, that is here. That is C. And enter. Okay, then again, let me tell you how to do this. Click this cell, then type the symbol equal. And we know, in the final step, we already have the value, the square value of this part that is here. So click here, and the value is E5. E5 is here, and slash, it means the division, divided by C5, the value is C5 is here, E is here, E is here. E expectation or expected value, because we think when we throw a die, the chance of 6 area, they are equal, right? So we expect when I throw the die for 600 times, we expected that the point of 1, point of 4, point of 3, they are 100 of each one. So that is our expected value. And the abbreviation is E. And the formula is here, divided by E. And it's easy. You don't need to type the number, because the Excel or the Google spreadsheet, it has the smart function. You just type here, then divided by slash symbol C5 here. C5, then this value is this cell per this number. Oh, sorry, I may postpone the break time a little bit. Is it okay? Then tell me how to calculate the sigma here. Maybe I need 5 or 10 minutes more. So, okay. How can I calculate sum, the sigma symbol here? The sum of each one, we have 6 sets of number. We have 1, 2, 3, 4, 5, 6. How can you get the sum of? Oh, it's easy. Let me calculate by my brain. That is 25 plus 25, 50, 16 plus 16, that is 32, and put them together, that is 86. Yeah, no, don't worry. The number is 6 sets. If you have 600 sets, 1,000 sets, you cannot do that. You cannot do that. So let me tell you. You can type here. For example, here I have the and I sum here and click equal. Oh, yeah, that's smart. From F5 to F10, you can do it, or you can type it by yourself. SUM parentheses, and move your cursor back to the parentheses. Then select this range. Click the mouse key. Hold the mouse key until you select the whole range. Then release your mouse key. Then click enter. We will get the sum, the value here. That is sum of here, and 25. Is it okay? Okay, later I will share this file to you, and it's my example. The copyright is mine. I will release for everyone to free to use. Okay, don't worry. Then click enter. Okay, the value is 82. The value excuse me, is 82. One more question. What about the degree of freedom, abbreviated as DF? DF, degree of freedom. Degree of freedom, let's check the formula. Degree of freedom, that is K minus 1. Remember, degree of freedom, always the simple number minus 1. It's the iron rule. Okay? Then we have, how many samples do we have? 1, 2, 3, 4, 5, 6. So the degree of freedom is 6 minus 1, that is 5. Degree of freedom, that is 5. All right? Because we have 6 events or 6 numbers, degree of freedom, that is the number minus 1. In this case, that is 5. Okay, let's check the final step. Believe me, in the final exam, just a reminder, in the final exam, I will ask you to have this kind of example. Sure, in the final exam, you are able to use any kind of electronic device, paper notes, but no talking. Only one restriction, no talking. You can use any kind. You can review my video. I will be very happy because you click it. Okay, then, then we are entering the final step here. So we want to know, we set a confidence interval about 5%. Remember, 5%, it means it's a very common threshold, the common level, because if the chance is less than 5%, p-value is less than 0.05, it means the probability is very small. Probability is very small. What does it mean? If the p-value is smaller than 0.05, it means this die is a strange die. It's a strange die. It's not fair. Maybe cheating, some cheating device inside. If the p-value is greater than 0.05, maybe you cannot say that that is a cheating device. Okay, now, we are going to the last step. Check the table here. And I just, there are tons of tables on the internet. I use this one from the Department of Math, University of Arizona here. Okay, let me indulge it. Okay, my question, actually, from normal distribution, there is a similar table. From t-test, there is a similar table like this. From chi-square, there is a similar table like this. From f-test, I think f-test is not so important for you, but I will check it whether we have time to use the f-test. And now, I just mentioned, what about the 0.05? 0.05 chi-square, the here 0.05. Then what's the degree of freedom? From the y-axis, this column, degree of freedom 1, 2, 3, 4, 5. Our answer is 5 because in our case that's 5. And check this value. As long as the value different from 11.070, it means it's different. it's different. Okay, and it's larger, actually it's larger than this number, then we can say that is significantly different. Is it okay? Okay, have a 10-minute break, then we will come back. I will review the whole process again.